I'm Katherine and I am a second-year graduate student in chemical oceanography. So what I do in oceanography is I look at the interactions between nutrients in the upper ocean and the critters that do photosynthesis there. So I work in a lab that's an organic chemistry lab. So we're interested in certain organic biomarkers, and some of those biomarkers that tell you which creatures are there, or sometimes they can be used for like temperature and all sorts of different markers. Some of those biomarkers are in very, very low concentrations, so you need to filter a lot of water in order to get a signal on our instruments to tell you how much is there. So for lipids, for instance, we filter between 10 and 20 liters, and then for one data point we need 10 or 20 liters. And we use these larger filters so we can filter it faster, and just so it's more feasible to filter that much water. And then other things we're only filtering 500 mils, and then what we do with the filter is we have to pack it into a tiny boat, into a tiny little pellet in order for it to be analyzed. And so in that case, it's more important to have a tiny, tiny filter and go a little slower. So it depends on like what you're going to do with the filter. If you can use a big filter, it's better because it's faster. But sometimes a smaller filter is better if you need to like pack it into a tiny pellet or something like that. So it depends on what kind of analysis you're going to do. But our lab does a lot of different chemical analyses, and so we take samples when we're out here, when we're in the field. We take samples for anything and everything we could think of at the moment, and hope that they're the right ones, pretty much.